Hello and welcome to another episode of Invalid Entry. My name is James Taylor and today we're looking at advent of code and some more security related things. So what we're going to start with today is cross-site request forgery. Cross-site CSRF. Cross-site request forgery. Going back to basics, we talked about this the other day when we talked about sessions, is if you imagine that your web browser is a box. And when you're accessing a website, which is a server over here running some code, you make a request to it and it comes back with an answer. And that answer may contain cookies, usually your session cookies if you log onto a website. So inside your web browser, you have these memory buckets of cookies. So this is site 1, site 2. And the idea is when you have another tab open, it doesn't even have to be another tab, it could be the same tab later on, or it could be another browser. Unless you're swapping profile, Chrome has the concept of profiles, and incognito is a form of profile as well. Every time you request site 1, it will transfer the cookies. This is site 1. It will transfer the cookies over saying, hey, do you remember me? I was session 27, I was user 14. And hopefully there's assigned cookies and so on. But you're looking at the web page and you're doing your cool stuff. And then what happens is you don't log out because no one ever logs out of websites because we like the convenience of being able to go back to them. Or, as I say, it's another tab and you're still doing some work on that website. And you go to site 2. And we can presume site 2 might be malicious. It's written by this angry, malicious person. And what they've done actually is craft a web page which is going to cause your browser to make a request to site 1. And that may be done by a few things. So you go there, maybe you've clicked a link on a Twitter link, or you've clicked some other untrusted link, but you've gone to this website and it has downloaded so you've requested a page and it's come back down. And that web page, even though it's in the site 2 domain, maybe it contains a form, so it can contain a form. And the action is site 1. So the action on this form will send a request to site 1 from your browser. And that's really important because it's going from your browser, it will contain the cookies from your browser. Or it contains some JavaScript, and that JS might making requests. So you don't even have to click anything, it will just do it in the background of the page and start running things against site 1. Again, requests coming from the browser to site 1 will contain site 1's cookies. This was on purpose. This was designed on purpose back in the day for you to do like marketing cookies, advertising cookies every time I request. I want to be able to embed content from another site into my site. For example, I might want to do a YouTube video on my website homepage, or I might want to include a discuss comment thread on my page, so you can embed other people's website content onto your page. There was a lot of marketing stuff, a lot of advert sites popped up this way, so I'd like to load adverts from like Google adverts onto my website. And that's how it works, is you're basically legitimately embedding your content, so yes, reach out. In this situation, this is called a cross-site request forgery because site 1 does not intend for site 2 to be generating pages that talk to it. And what will happen here is if you don't put CSRF protection in, it will break. So I'm going to show that in action right now, and then I'm going to show a demonstration of how to solve it. One of many methods, but the method which are most commonly used to solve this. Okay, so here we have the world's worst website, version 3. It now doesn't have SQL injection, it's now got validated session cookies, but it does have the CSRF. So I've got a second website here running on a different port. I know they're on the same domain and that can be weird on cookies and you might be able to access, but ignore that for the moment. The main thing here is that this website, the pink website, when I hit submit, it actually makes a form post to the first website. So if I refresh this, you can see it's adding in extra posts. Every time I click that, it will do that cross-site request. And the reason for that is basically, if you look at the code to this website, it's just a simple page which is going, yes, make a form post here, and it basically contains the body as a hidden field. It doesn't even have to be a input field, and it's got the value that's going there. It says ho 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 there, and that's because I didn't restart my service. So I should restart the server, reload this, and post. It actually do ho ho ho's. Well, it should do ho ho. I restarted the wrong one here. Rid of that. There you go, ho-hos, there you go. I'm cross-posting this. So basically I'm now able to inject You can hide that. You can do stuff with JavaScript. You can do stuff with iframes and things to make those posts very almost impossible to see. There are some elements of the browser which they've started to bring in to help protect against cross-site requests. One of the things now is that the first site actually has to put in a header that most modern browsers, and I stress most modern browsers, will obey. So if I then make a request, because the header says I can't share content, it won't actually return the content of the body to the JavaScript in this other domain, unless I said yes, allow this other domain to see the return API. The problem with that is the request has still happened, so the response is a waste of time. Like here, it's a remote function call, so I've already called the function, the effect has already happened, I've already injected. So first that I've got more messages in here. The solution to this is a bit interesting, but basically it comes down to we want to modify the form. So we're going to look at the body form here. This is my post form. That's my login form. This is my post form. It's basically a text area and a submit button. That's all it is in there. What we're going to do is we're going to add a secret into this. So we're going to do text input type equals hidden, and then the value is going to be some secret. And that's important because the idea is that everybody will get a unique value. So I could include, for example, it has to be unguessable. It has to be unique and it has to be unguessable. So you could involve some kind of cryptographic hash that can be calculated from the user. But if it's something that is calculable, it could be something that could be what we call phished. You could convince the user to disclose that, or you could use another defect to try and work out what that value is. So if it was just like, I don't know, your user ID, MD5 of your user ID, for example, that could be worked out quite quickly. You could, if I had a legitimate user account on the system, I could look at the body and go, oh, look, this value is always the same. What we're actually going to do is we're going to include from UID import UID4. Okay, so UIDs are universally unique identifiers. They're basically short snippets of random numbers. What we're going to do is in the session section up here, we created these sessions to basically drop in. This was a signed session, but we're going to put in a UID. We're not going to bother signing it because I don't really care if it gets adapted or anything. So I'm also going to do response.set cookie UID or CSRF token, and it's going to be a str of UID4. So I'm just going to generate a UID4 and just set that. And it's going to be set on each session. So on logout here, I'm going to unset that cookie CSRF token. That. So I'm unsetting my CSRF token there as well. That on its own doesn't do anything. That just means next time I log in, I'm going to have a random UID. And we can test that here. If I open up the developer tools, on this, I want to show the application tab. Okay, so what we're going to do now is just log out and in again. I really need to put a link there. I also need to pick a shorter password for logging in. So if we now have a peek at the application, you now see there's this CSRF token, which is fantastic. It's not doing anything, it's not preventing any attack at this point. In the get session, in the process session, what we want to do is also grab that CSRF back. So at this point, session CSRF is equal to cookies request.cookies to get CSRF token. So now we've got it in our session, which we're using in all these functions. So in these functions here, we actually will have a reference to it because we have the session. So what I'm going to do here is I'm actually going to put it as the form body in this value here. So here, %s, drop it into my form, CSRF token. Hidden value, fantastic. So now what's going to happen is both as a cookie and it's the form body. The cookies, they should actually be set to being HTTP and secure, but they're not at the moment, which is another problem for another day. But actually we're still not validating that. So what I want to do now is, before we get down to here, ignore this massive post here, is we're going to process the session, as we would normally, to check that we actually logged in. Check that we logged in. And then what we're going to do is actually get, it says if the request.form, let's see, where was the form variable we used here? We didn't give it a name. Oh, here we go. Name equals CSRF. If the form CSRF is equal to, double equals, the session CSRF token, like that, then we continue with the work. Else return redirect. In fact, I'm just going to put a big no. Now that should do some logging. We should probably log that and raise some security alerts that someone's actually trying to actively hack our website at that point, because there's no way you accidentally make a post to this website and miss off the form elements if you're using the application in the intended manner. It's definitely someone probing our website at that point. Quick restart of the server, because it's a Flask, I have to restart the server. And what we should find now is, if I reload the page, we get an error because I missed an element, and the element was here. That has to be from the session CSRF token, because it's not actually a value locally. Very easy to make these kind of mistakes when you're coding on the fly. CSRF token comes from, it's just CSRF. It's just CSRF. Shouldn't cross-pollinate. In fact, I'm going to change that there. This is bad. This is bad to call it different things in different places. And then if I'm changing it there, I also need to change it here. There we go. That's better. I was thinking about it as I did it, thinking this is bad. So what we're going to do now is, if I now make a new post, if I actually view or inspect this element over here, you actually see there's a hidden value there, and I say it's hidden. I can see it in the source, so the person who owns the browser will be able to see that. And if I now post this, going, this is a legit post, and submit that, I get an error, which is wonderful. I just need to look into that, why that was a error. Okay, so I had not quite saved it, and that is a legit post at that point. So I hadn't changed the word from CSRF to CSRF token all the places. I missed one, but I fixed it now. So with the CSRF token in place, those two things match: the form post and the cookie match. If we now go back to our attacker here, the attacker, first of all, if I click to do it, I get the error, right? Because I haven't even tried to do it right. So as the attacker, I might look at my own web page. And every time I log in, so if I now open up if I actually look at the element here, inspect this element, you'll see that the form, the CSRF token is 349C, and so on. If I was to log out, which I still don't have a log out feature, I need to add a button for that, just to save myself. Inspect this element now, you'll see that the CSRF token is 9.2. It's a radically different thing. So if I was an attacker and I'd gone this, I could capture that element there and sort of add that into my form. I wouldn't know what the value for the person that I'm trying to inject was, so I'd have some random value in here. At that point, this wouldn't work as a post, because it's not going to match. So when I click that button, I'm just going to go straight to the error page going, that was rejected. And it is the going guessable. Now, there is a problem with the fact that the cookie is readable, is HTTP, so there may be other attacks we can do to get that cookie back. But fundamentally, this is the standard way of doing CSRF, is that you put a value in the header, and you then put the same value into the form post, or a related value that can be cryptographically very quickly validated to be in the same thing in the form post. Because it's very hard for an attacker to get both those elements back, especially with cause policy and so on. It isn't impossible. There are ways that people can make those requests. One of the ways is by browser extensions, what we call man-in-the-browser attacks. Man-in-the-browser attacks aren't quite the same as cross-site request forgery, because you have to install a thing into the browser, and then it can see the content of the page you're looking at. It's much harder to trick someone to install a browser extension than it is, for example, to send a link to their email or to Twitter or over Discord or something like that and say, hey, click this link. People are often more willing to click links than they are to install random bits of browser extension and so on. But yeah, it's a very simple trick. Is, as I say, put something in the body of the body here. Does every form need a CSRF header? Does the login page need one? No. But what you actually find you do is, when you're building a web application, a more complex one than just a simple Flask, is you start putting decorators on. So you say that every post request you make to a server has to go through the CSRF middleware and it has to be validated, and that's done invisibly, so you don't have to worry about doing it in code. So if you're in Django, for example, you just drop there's a token tag, CSRF token, you drop into your template, and that is automatically done. Every single form post has to have a CSRF value in, otherwise it'll get rejected by the middleware. And that means that you don't accidentally forget on one form not to do it. Again, this comes back to what I was saying in the last video. If you roll your own authentication, if you roll your own validation, you're trying to resolve problems that people have already solved. I do think it's worth people understanding this to understand why CSRF is important and why you shouldn't just blindly turn it off. There are situations you do want to turn it off. One of the situations you want to turn off that global CSRF banning is if you have APIs, if you have a RESTful API, for example, or APIs which take post requests. They might not be taking form post requests, but they're still taking post requests. You will not have CSRF tokens in those. So you want to say these particular URLs or these particular group of URLs do not require CSRF validation before you process the body. In those situations, you want to put other authentication or authorizations on. So you wouldn't be using cookie session-based authorizations. You'd be using bearer tokens, JWTs, other validation of the user on every single request rather than using a session cookie type thing. And that's it. Hopefully you found this helpful. Hope you found this informative of what CSRF is and how trivial it is actually to defeat it, especially on the form posts. And yeah, hopefully you're finding this useful. If you are, please hit like, please hit subscribe, and there'll be another video tomorrow.